also highly side effects వస్తాయి.
Masalah. Di pa mo. Coba, ayah sudah seneng kemana lah, nah.
Tanya bisa
Am I audible to everyone? Okay, okay. But still, more than 30 people has to arrive. Um, everybody should be sharp at time so that we will discuss all the concepts within the available time. Right, let us start today's session. In the last class, we have discussed something about the core components of Hadoop, what exactly the Hadoop environment, and uh, the factors that motivate us to develop the Hadoop environment. So these things which we have discussed in the previous class. So in the previous class also we have discussed the Hadoop ecosystem. That means the components which are present in the Hadoop ecosystem. In that the Hadoop common, HDFS, Hadoop yarn, Hadoop MapReduce. So these are the some of the important components of Hadoop through which we can perform all the operations, right? So, and even we have discussed what factors that motivate the people to develop Hadoop environment. All right. So now let us start discussing about the Hadoop distributed file system, which acts as a storage for the Hadoop, like ordinary file system in our ordinary computers, right? So Hadoop distributed file system is meant for storing the files as the way it was developed based on the Google file system concepts, the white paper of the Google. Okay, so based on that, in the similar way, it was developed. The core concepts are same for both Google file system and Hadoop distributed file system, whereas Google file system is meant for solving the problem of Google only, whereas the Hadoop distributed file system it is a open source. Hadoop itself is a open source software framework which can be used by many organizations to solve their problems. Right now, let us see how the Hadoop distributed file system will work and what are the building blocks of the Hadoop distributed file system, and we will discuss about each and every component of the Hadoop distributed file system in our today's class. Okay, so now let us talk about the overview of the Hadoop distributed file system. It is responsible for storing data on the cluster, right? So as we have discussed in the previous class, the design assumption or the main goal of developing Hadoop is it need to work on clusters of commodity hardwares, cheaper hardwares, and with that clusters of commodity hardwares, we are able to store huge volume of data in various clusters. So here, irrespective of the file size, we are able to keep it in our Hadoop environment. So the HDFS will act as a file system for the Hadoop. So file system will help you to keep your information internally. So that is the reason the Hadoop distributed file system, or simply we can call it as a HDFS. Okay, so HDFS is responsible for storing data on the cluster, and the data files are split into blocks and distributed across the nodes in the cluster. As you all understood while discussing GFS, what is the functionality, what way either GFS or Hadoop is going to handle the huge volume of data is initially whatever the file which is it is going to be processed that need to be split into blocks, and those blocks are distributed to the data nodes. Okay, so where we will perform the actual operation. That means whatever the operation that the user wants to perform on the data, okay, so that operation will be performed at a data node side. Okay, data node, you can call it as in the data node. So whereas in the case of Google file system, it will be done at a chunk servers, right? Don't worry about what is data node and all. Very soon we are going to discuss about it. You just imagine that both chunk servers and data nodes are same. Whereas when I use the word name node, which is similar to the master node in GFS. Okay, you just imagine these two until we will discuss the HDFS architecture, right? Master node is a name node is a name node will act as similar to the master in GFS. data nodes are acts as a similar to the chunk servers in GFS. Okay, because you are aware of the functionality of GFS. Okay, all right. So the data files are split into blocks and distributed across the nodes in the cluster, right? So whatever the file which you want to process, that need to be split into blocks. There we will call it as a chunks. Here we will call it as a blocks only, right? The same limitation of size, 64 MB. Of course, here it allows you to process the block size is 128 MB also, 128 MB also, right? So initially, here also the assumption is 64 MB. The whatever the file which you want to process, that need to be split into 64 MB blocks, and those blocks will be supplied to the various nodes which are present in the clusters, right? And each block is replicated multiple times. As you know, why we need to replicate the same information, why we need to maintain Xerox copies of the original information. Here also, the default assumption is we'll maintain 3 replicas as the way in GFS. Okay, so in that, one will be stored in local system and the remaining 2 will be stored in remote systems, right? So in such a way, the replicas will be stored. So these are the fundamental responsibilities of the HDFS. Now let us look at about the HDFS architecture. As I told you, in Hadoop environment, the data will be processed with the help of name node and data nodes. Name node and data nodes. There are here n number of data nodes are present in the clusters. Say for example, if you think about rack 1, rack 2, where we will keep the servers, you know. So in such a way, rack 1, rack 2. That means here in the rack 1, we'll find 3 nodes, whereas in rack 2, we'll find only 2 nodes. Don't think that only limited number of nodes are present in the rack 1 and rack 2. There are thousands, billions, hundreds and thousands of nodes are present in the cluster. Imagine that this is a cluster. That means simply you can assume that this is a group of systems with a similarity. Cluster means you studied in the data mining clustering. Clustering means making objects into a group based on certain similarity. Either maybe centroid, by calculating centroid, distance. Like there are several factors to find the similarity among the objects, right? So these are the group of elements. Say for example, you can imagine that all the systems which are present in our lab 1, this is a cluster 1, and this is another cluster. You can assume that this is all the systems which are present in the lab 4. Lab 4. Okay. So now lab 4 acts as a one cluster and lab 1 acts as a one cluster. Okay. Imagine rack 1 is similar to our lab 1 and rack 2 is our lab 4. Okay. So now what happens is, whenever if a client made a request to process a file, okay, immediately the name node, of course, we need to discuss so many functionalities of the name node in future, how it is going to be respond to the client request. So until then, initially you just imagine that whatever the request here, client in the sense, again, same as systems to system interaction, not between the system and user interaction. Okay, so here client represents your application. Okay, whenever if an application made a request to process a particular file, so that request will be transmitted to name node. Actually, it is not directly transmitted to the name node. There is certain process should be exist before handling the request made by the client by the name node. But initially, you just assume that your request will be supplied to the name node itself, and name node will in turn, it is going to be assign the task to the data nodes, right? Here, name node will maintain all the metadata as the way master node maintains in GFS, right? So similar to that, it maintains all the metadata, that is files or files to block mappings, replicas information, like all the information, transaction log, operation log, all those are maintained by name node, right? And here it contains another part is called as job tracker. Name node consisting of another component. It consists of another component which will take care of supervising your activities. That means the job tracker responsibility. That means whenever if a client made a request, name node in turn it will be transmitted to job tracker. What job tracker does is Job tracker will look for the content, the blocks where it is available, and as well as replicas information. So once it was placed in the HDFS successfully, the job tracker will try to assign the task to the data nodes, because that job, once you split into blocks, those blocks need to be supplied to the data nodes where the physically it need to be stored and it need to be processed. Suppose, say for example, if a block is submitted to this particular first system, right? In that case, whatever the block that it was transmitted to this particular one, that will be done by job tracker itself. And here in the data node itself, it contains another component, important component, that is called as a task tracker. Task tracker. What task tracker does is, whatever the task that was assigned by the job tracker to this particular one will be processed. That means it supervises the execution of a particular task in the data node itself. Okay. So in such a way, it is going to be performed. So we will see in detail about all these things in later slides. So the name node is the primary node, which acts as the whole supervisor for the entire HDFS architecture. Okay, so it processes all the requests made by the clients with the help of data nodes, right? So here you can observe that a client can read the information directly from the data nodes, and he can write the information directly into the HDFS. Client is the outer part, whereas name node, data nodes, all these are under the HDFS building blocks, right? So the client can read the data. Here it follows the mechanism of once you write, and you can read many times. So which help you in implementing the coherence also. So if you write once, you can access any number of times. Usually the modifications will be just simply, we will append. Suppose if we did any modification, simply we will append. So in such a way, it will work. Now, let us talk about the basic concepts of HDFS. HDFS is a file system written in Java based on the Google's GFS, as I told you, which is very similar. The functionality is more or less similar to the GFS. It provides redundant storage for massive amount of data, massive amounts of data. That means you can store irrespective of the file size, and you can process even though it is large file. So the HDFS is able to accommodate your file, whatever it may be the size of it. And HDFS works best with a smaller number of large files. Smaller number of large files. That means at a time it is able to process 3-4 large files. Okay, millions as opposed to billions of files. Typically 100 MB or more per file. So that means it defines the how large it becomes. So it gives you some assumption like what way you are supposed to assume the size large. So these statements are meant for that assumption. Okay, you can imagine in such a way. Files in HDFS are write once. We'll write only once, and we can access many number of times. And optimized for, because each and every time when you are doing operations on it, you need not write each and every time into the HDFS, right? We will see while executing programs how it will be done and all. Until then, you just remember this point. Optimized for streaming reads of large files and not random reads. So our basic assumption even in GFS also, what it does, it allows large streaming reads, but not small random reads. But here it won't allow you for the random reads. It will allow you for the streaming reads of large files. So as we have discussed, what is the necessity and what way it improves the utilization of the bandwidth and all the things while discussing the GFS. Now, how the files are stored into HDFS. So files are split into blocks. Blocks are split across many machines at a load time. See here, it follows the efficient load balancing mechanism. Of course, still a lot of research is going on in developing the efficient methods for the load balance, because each and every time when we are processing the data, keeping a huge volume of data forever Forever in the sense, when you are keep adding files to the storage area, definitely over a period of time, it is also going to be filled. So what happens if we increase scalability? Scalability in the sense, when you are adding number of systems to your clusters, your performance of your HDFS or your Hadoop system should maintains the same as before addition also. That means your efficiency should be very well, even though when you add number of systems to the clusters. So in all these cases, load balancing factor plays an important role itself, right? So of course, anyway, the basic Hadoop itself, it is able to handle this situation, but lot of advanced methods are going to be developed for handling today's huge volumes of data. So blocks are split across many machines at load time. Different blocks from the same file will be stored on different machines. Here you need to remember this point. Different blocks from the same file will be stored on different machines. As I told you, always they will be stored randomly at different systems. Okay, so the same file blocks may not be stored in single data node. Okay, and blocks are replicated across multiple machines. As I told you, first block will be stored in local file system, and remaining two blocks are stored in two different remote systems. The name node keeps track of which blocks make up a file and where they are stored. So the mapping between the file and the blocks are maintained. Namespacing is maintained by the name node itself. In such a way, the files will be stored in the HDFS. Now, here, as I told you, it maintains the replication factor as 3 by default. You can assume that these are the 1, 2, 3, 4, 5 are the input file blocks. So probably node A, node B, these are the nodes, data nodes, which are present in the cluster. You can think how this second block is going to be placed in all the systems. You can see node A consisting of the second block, and node B consists of the second block, right? The third one will be stored at node D. Just it is a this diagram shows the illustration what way they were stored, not exactly this same pattern, right? Okay, so you can observe that the remaining blocks may be stored in different systems. In such a way, the file blocks are going to be distributed in HDFS. Data retrieval, how to retrieve the data. When a client wants to retrieve the data, communicates with the name node, because that is the entry point from where we need to get some permission to access the data. So communicates with the name node to determine whether blocks make up a file and on which data nodes those blocks are stored. Okay, so whatever the file which you want to access, okay, so the name node has to verify whether the file is exist in the HDFS or not. Okay, suppose if it is exist in the HDFS, where how many blocks it contains and where those blocks are stored in the data nodes, these all the information need to be gathered by name node, and then communicated directly with the data nodes to read the data. Once it acquires all this information where the node blocks, I mean the data blocks are available at the nodes, that information will be passed to the client, so that the client can access the data directly from the name node. Okay. So now let us talk about what are the functions of name node, what name node does. So it manages the file system namespace. That means maps a file name to a set of blocks, maps a block to the data nodes where it resides. So as I told you, the blocks are physically stored in data node only. Only the job of name node is just it creates the blocks, and those blocks will be distributed to the data nodes. Those blocks will be distributed to data nodes. Those data nodes will keep it for the further process. Okay. So cluster configuration management, right? How do we set up the cluster? So after discussing these HDFS, we are going to discuss about the configuration modes. 3 ways we can configure the Hadoop in your system. One is standalone mode, second one is pseudo random mode, and third one is distributed mode, right? So both standalone and pseudo random modes are installing it, are working with a single node. That means with a single system, your system itself, you can install the Hadoop in two different ways. So what is the difference between those two is, in the standalone mode, both data node and name node are present in your system, single system only, and which works using single JVM. With the help of single JVM, it works in your system. In pseudo random mode, both name node and data node are present in your single system only, but where it can be processed by multiple JVMs. That is the difference between standalone and pseudo random mode. In the standalone mode, only one JVM will be there, whereas in the pseudo random mode, will work with the multiple JVMs. But in both the cases, the name node and data node are stored in single system. So why we need to have this kind of configuration environment? You might have a doubt, right? Whenever you are going to install it, you need to be tested. You need to test it. Right? So for the testing purpose, always we'll develop the applications either in standalone mode or the pseudo random mode. Of course, we will discuss in detail about all these things in the later sessions. When coming to the third type of mode is distributed mode, where the name nodes are present in one cluster, whereas the data nodes are present in different clusters, and it uses many JVMs for the processing. In the first two configuration modes, we will work, we'll install both name node and data node are at single system, whereas in the distributed system, we will store the name node at one place, these data nodes are at different clusters. Imagine that our server in our college, the server is present in the library, we'll assume that it is a name node, and each and every lab will act as a cluster, where the cluster contains different number of, right? So data nodes may be present in all the cluster nodes. You can call it as a data nodes, right? So the name node can store, whenever if you made a request, the name node can store the information in any one of the clusters, right? So in such a way you can imagine. So cluster configuration management, and third one is replication engine for blocks. Replication engine for blocks. So how do we maintain the replication factors, and how do we manage, and even in the GFS also we have discussed re-replacing, re-replica management. So these are all things we have discussed in the previous classes. So here also it maintains the replication engine for blocks. So now let us talk about what kind of data the name node is going to hold. So as I tell you, the complete metadata, that is data about the data, is maintained by the name node. So metadata in memory, what it maintains internally in that particular system where the name node is running, the entire data is in memory. No demand paging of metadata. In the OS, you might have studied about demand paging, how to retrieve the page, okay, and how to retrieve the that particular file. You can imagine, right? These two things are stored in the main memory. So now let's talk about the types of metadata. What are the types? List of files and list of blocks for each file. How many number of blocks that it contains? Okay, and list of data nodes for each block. List of data nodes for each block. You can see. So here the block 2 is present in node A, node B, and node D. Okay, so node A, node B, node D are the data nodes for the block 2. Like these are the blocks of the file. Okay, so list of blocks for each file, list of files, list of data nodes for each, and file attributes like example, creation time, replication factor. So these are the different types of metadata that will be maintained by the name node. Along with that, it also maintains a transaction log. That means records file creations, file deletions, etc. because whenever this everything, this total process is going to be performed automatically. So in that case, whenever if you delete a file, there should be the space is going to be free now. Okay, so how that free space will be known to this, so that whenever next time when we want to store some information, okay, so for placing that information into the different places, the name node has to maintain the information regarding where the free space is available, right? Suppose in lab 1 all the systems are their memory is filled with the blocks which are already assigned. So next time what name node has to do, it has to move to the other cluster where it is free. Otherwise, if it continuously try to store the information in lab 1 systems, what happens in that case? There is no space available. So even though you try to keep the information, what happens in that case? We can imagine, right? So that is the reason continuously it need to be supervised, the free space and balancing, because that is also an important factor. If so, if you define an efficient mechanism how to find the free space and how we are going to be place equal load on each cluster, it is also another important point. As in our college, let us assume that we have 4 labs. So lab 1, lab 2, lab 3, lab 4 clusters. You always, if you try to assign the task to only lab 1 only, you keep it lab 2, 3 are standalone. What happens in that case? The lot of load, lot of pressure is there on cluster 1 systems. So instead of pressuring all the things, as the way you can think about how do we assign berth reservations in the train reservation system, how it is going to be assigned, what way it is going to be balanced. So for each and every time when a seat is going to be reserved, okay, so always it is supposed to follow the balancing factor. Otherwise, if it follows the mechanism of first come first serve, that means first to complete sleeper coach 1, and then sleeper coach 2, sleeper coach 3, and sleeper coach 4. In such a resume, if follow that, what happens is someone purchases their tickets in coach 1. In that case, before starting the train, coach 1 is empty, remaining 2-3 coaches are filled. So in that case, there is some balancing problem. It leads to some technical issues. So that is the reason always you can find at any given point of time almost all the bets in all the coaches are same. Same in the sense, maybe 1 or 2 differences will be there, but majority of the cases, all the coaches are filled with equal number of seats. So in such a way, here also we need to be balanced all the clusters. Not only clusters, cluster contains a group of nodes. Again, the group of nodes are also be distributed with equal workload. Then only we are able to get the maximum throughput from the Hadoop. Otherwise, the performance gets slow. Okay. So for that reasons, we will use these transaction logs also. And a file system in metadata. Okay. So the HDFS namespace is stored by the HDFS namespace is stored by the name node, as you are aware of that. Name node uses transaction log called edit log. So the name of the transaction log in HDFS is edit log. Okay. So here we will call with this name to record every change that occurs to the file system metadata. Every change that occurs to the file system will use the edit log to record it. So that will be maintained by name node itself. So file system metadata are, for example, creating a new file. Creating a new file. When you try to create a new file in HDFS, whatever the process that the specifying the attributes during the creation, right? These all things will be recorded, and a change replication factor of a file. As I told you, by default it was defined with 3. If you want to increase, yes you can. If you want to reduce, yes you can. So whatever it may be, the factor that defined by the client that need to be recorded. Okay, so edit log is stored in name node's local file system. That means local storage area where the name node is running. The entire file system namespace, including mapping of blocks to files and file system properties, is stored in a file called as FS image. This is very important. We'll use this word later in our further discussion. FS image. FS image is the file which is used to store mapping of blocks to files and file system properties. Okay, which is also be stored at name node's local file system. That means which is also be stored in the system where the name node is running. Okay, so this is file system metadata. Now let us talk about the functionalities of the data node. Right, so a block server, it acts as a block server. That means it stores the data in local file system. As I told you, the main name node is going to be split the given file into blocks, and those blocks will be supplied to the data nodes. So data node has to keep it for the further processing until it got a request from the job tracker to process it, or until it got the information from the job tracker what it has to do with the block. Okay, and it stores the metadata of the block. It maintains the information of the block. That means to which it belongs, which block is to which file it belongs, okay, when it was created, and all the things, the size, all the attributes which are required to define a block, those will be maintained by the data node, and it serves as a data and metadata to clients. Okay, whenever if a client get a permission from the name node, in that case what happens, the data node has to supply the metadata and as well as original data to the clients. Okay, and block report periodically sends a report of all existing blocks to the name node. As you might have heard about the word heartbeat. Heartbeat is a controlling signal through which every data node is going to be communicate with the name node regarding their activeness. Okay, whenever if the name node receives the heartbeat from a particular data node, what it is active. Periodically, the name node scans the heartbeats from the all the data nodes. By using that, it is going to assume that how many number of nodes are working, so that it allocates, it distributes the blocks to the various data nodes based on their activeness, right? And it facilitates pipelining of data, right? As I told you while discussing about the chunks, what happens is, so always the client look for the nearest block where it is available. Because suppose you can assume that lab 1, 2, 3, 4, you are at a FED block. You are at a FED block. So always what you have to do, you need to try to connect to the lab 1 because which is nearest to you. Okay, so in such a, so that what happens, it minimizes the bandwidth utilization. Suppose if you try to connect from flat block to the fourth lab, what happens, it need the data, whatever the information which need to be traveled between you and the cluster 4, so that need to be traversed or that need to be transmitted for long distance, so that what happens, your bandwidth is going to be killed. So that is the reason always the client is interested in connecting to the nearest one, right? Okay, you did something with the nearest block, whatever you have accessed. So those modifications need to be updated in other places where the same block is available. Am I right or wrong? Because whenever if it gets failed, if a name node gets failed, what it has to do? So in order to get the latest information regarding all these blocks and all, okay, we need to maintain the information with all the other nodes. Okay, so that is the reason whenever if one particular block is updated at one particular data node, the same need to be rewrite in the all other places where it is available, so that all the systems will maintain the same information, right? In block replacement. So current strategy is one replica on local mode, as I told you, second replica on remote rack, and third replica in also on the same remote rack. So that means 2 copies are maintained at same rack, which is a remote one, whereas third record will be maintained in a local mode, for which will be used for a faster process. As I told you, always you try to connect to the nearest one. So by keeping the one block at the local node will help you to minimize the traffic. Okay, and additional replicas are randomly replaced. The randomly placed. That means, suppose if you want to maintain 5 replicas, okay, so the first 3 will be stored in this fashion, and remaining 2 will be distributed to. There is no mechanism, standard mechanism for it. Randomly, we will define a mechanism of how to assign it randomly. So, for the remaining 2, it follows the random distribution, right? So, clients read from the nearest replicas, as I told you. Okay, always try to read the data from the nearest one. So, would like to make this policy pluggable. That means wherever you go, it can be easily plug in, just as the way how do you add charger to your mobile phone. In such a way, it is going to be the block replacement policies. Right, heartbeats, as you know, it is a control signal. Data node sends a heartbeat to the name node once every 3 seconds. 3 seconds, whereas in the GFS, it is for 60 seconds. But here it is only 3 seconds. So for every 3 seconds, the data node is going to pass some information to the data node regarding its activeness. Name node uses heartbeats to detect the data node failure. Suppose whenever if it did not receive any heartbeat from any one of the data nodes, what happens in that case? It assumes that name node assumes that the system went wrong, or the failure may be occurred with that particular data node. Now, another important point along with the name node and the data node is secondary name node. So just simply it copies the FS image and transaction log. FS image file contains the mappings of files and blocks and the namespace of the files. Okay, and transaction log, that is edit log. Edit log maintains the creation, all the file attributes, creation, removal, deletion. So these all things are maintained at the edit log. So these two will be maintained by secondary also. Okay, so the copies FS image and transaction log from name node to a temporary directory. Why we need to maintain secondary name node is whenever the primary node gets failed, because this is the single point of failure for the entire system. Suppose if the data node gets failed, you have an alternative of a number of data nodes are available. So with the help of those systems, you are able to continue your process, continue your work. But if the node system gets failed, that means that is the supervisor, that is the entry point for your operation process. So if it gets failed, what have to do? As we have discussed in fault times, within no time we are able to restore it and restart it. Restore and restart. Restore whatever the your system before failure. Okay, to be start with the same. That means after failure also you are supposed to be in the state similar to that. Restore the restoration. Restart immediately. For purpose, keep all these backups in name node. Whenever if the project failed, secondary will look after all these things. All these things, it will not act as a name node. It will not be considered as a name node. Just it maintains the backup. Right? Is it visible to everyone or not? Is it visible or not? Okay. Okay. Right. So, so after restoring the content from secondaries to the primary name node, what primary name node has to do is simply it polls. It conducts a poll like regarding the information which is available at data nodes. That means each and every data node has to respond with the what are the blocks, number of blocks available currently in the system, and block sizes. Each and every information regarding the blocks need to be submitted to the name node. What name node does with that information is simply it verifies whatever it was restored from the secondary node. Okay, both the contents are verified. If both of them are same, it is fine. Otherwise, whatever the new content that it was received from any one of the data nodes will be updated at the name nodes data storage area. Okay, in such a way, the secondary will act as a backup for the name node, but it won't act as a name node. You just remember that important. That is very important. Okay, so merges FS image and transaction log into a new FS image in temporary directory. Okay, so and as we have discussed at this point, uploads new FS image to the new node. Transaction log on name node is plugged. Whenever the new system has started, okay, immediately these two will be moved to that. That is the responsibility of the name node, secondary name node. Now let us talk about the map reduce programming model. Okay, so it is a method for distributing computation across multiple nodes. With the help of this map reduce mechanism, we are able to distribute our task into number of systems, number of nodes. So each node processes the data that it is stored at that node. As I told you, the blocks are distributed to the data nodes. Okay, so those data nodes are stores the blocks physically in it and process it. The processing of that particular data is also be done by data node. Okay, you can imagine each node in the sense each data node processes the data that it is stored at that particular node. So it contains mainly two phases. One is map phase and another one is reduce phase. So what is the features of using of this kind of mechanism is automatic parallelization and distribution, because parallelly all the tasks are going to be executed, because node 1 will be assigned with block 1, node 2 will be assigned with block 2, like that all the blocks are distributed to the various nodes, and the data nodes are responsible for storing and processing of the data. So what happens in that case, block 1 will be processed at the same time, block 2 will be processed, block 3, block 4. So in such a way, the whole file is going to be processed and processed parallelly, and it follows the mechanism of distribution. Simply distributes to the all the system. And fault tolerance in the sense, whenever if the system gets failed, suppose if the data node gets failed, with the help of replica mechanism, we are able to process, right? Then it provides a clean abstraction for programmers to use. So you may be experienced, because you might have experience with writing the programs in C, C++, Java, Python. Okay, so now you just try to you can easily adopt this mechanism, how to write the map reduce, mapper logic and as well as reducer logic, and with that how do we handle the huge volume of the data in very soon, right? So you can think that this is the input file, which can large in size. That's why I was represented as a big sphere. Okay, so here it is a large volume, terabytes of size of data. So that will be split into blocks. Those blocks are assigned to the mapper logic. Okay, each mapper logic will process a part of the original file. Okay, map 1, map 2, map 3, map 4. Okay, so here there is no restriction like how many number of times. In general, we will write single method. By using that, we are going to be. But internally, how it is going to be happen is in this way. So that's why we need to be represent it as a different mapper blocks, right? For better understanding, only we wrote like this, right? Whatever the block that it was assigned to the map, right? For example, counting of the words, right? So whatever the number of words which are present in this block will be counted and assigned with the count also. Map word 1, whatever, how many number of times it was repeated. Say for example, 1 time. Previously we have discussed the word count example, where we have discussed it probably in wrapper classes and all, right? So whatever the number of times the word which is present in it, will be counted, and like all the words will be counted here itself. Similarly, map 2 is also will count the number of words which are present in the block 2. Similarly, third. So after that, these outputs of the map 1, map 2, map 3 will be shuffled or combined by using 3 different mechanisms. Okay, this is shuffle logic. These will be directed to reduce. Okay, so reducer will produce. You can imagine that this is the functioning which is going at a combined place, right? The reducer will shuffle and combine the outputs produced by the all the mappers. Okay, finally reducers will produce the final output, right? So here there are so many again research issues. What happens if we are using only one reducer? Performance issues. What happens if we use n number of reducers, n number of mappers, whether they influences the performance of the system or not? So these are the research issues. Still a lot of research is going on in these areas also. Can we write the programs without using reducer logic also? That was also be implemented, but performance wise, if you think the having a reducer will give more performance than no reducer. Okay, so of course we will develop the program using multiple reducers, single reducer, and without using reducer also, right? There you can understand the performance of this particular mechanism, right? So now you can this is the diagram which clearly explains what happens if a map reduce task is executed in Hadoop environment. You can think this diagram, you can observe this diagram. Client program is submitted to job. As I told you, master node contains, the name node contains the job tracker. What it does is it assigns the submit whatever the job that it was received, that will be split into blocks. Those blocks will be assigned to the various data nodes. Okay, this is called as, this part is talking about the physical storage, distributing the blocks to the various data nodes. And another component is task tracker. Task tracker in the sense, so the whatever the block that it was supplied, that will be handled, that will be processed by task trackers itself. Okay, the task tracker will fetch the information from the DFS. Okay, so what happens in the map phase and what happens in the reduce phase? So in the map phase, these process is going to be done, because you may not be clear as of now, because you are very early to listen all these things. So that's why you may not clearly understood, of course. But until then, you just remember that there are two phases are existing. One is map phase and another one is reduce phase. Just map phase will act as a filtering process, okay, which filters something. Not filtering, just it is a consolidation mechanism. And then we'll apply the shuffle process. Okay, so that is about introduction to the map reduce. We will see in detail about the remaining components of remaining parts of map reduce paradigm in the next class. So now it is open for the question answer sessions. If you have any queries in this, regarding HDFS or introduction to the map reduce, you can ask the questions now. Mon browser once again post the absentees.
Those four numbers only absent, sir.
Sorry?
Those four numbers are absent.
See, I did not have those four numbers. Even you can read out, because I was closing that chat box. That's why I'm unable to read. You can read those numbers.
D1, D2, H2, H4.
You can place it in chat box, sir. You can place it in chat box. Yeah. Any queries? Even I have shared a GFS original document in your group. You please go through it. It is an important important to understand HDFS, not only GFS. So today's absent is, you can see in the chat box, B1, G2, H2, H4. Only 4 people are absent for today's class, right? Any queries? Okay. If there is no queries, I'll end the session now. Okay. Thank you.